Okay, hi everyone. I am back with my maths homework, which I left incomplete last night. The first question is the sum of 10 terms of the series x plus 1 by x squared plus 1 by x squared plus x cubed plus 1 by x cubed squared all the way till x to the 10th plus 1 by x to the 10th whole square. What is that sum going to be in terms of x? Okay, so what I'm going to do is that I'm going to look at the general term of the sequence, which is x to the n plus 1 by x to the n and that thing squared, which can be written as x to the 2n plus 2 plus 1 over x to the 2n. Okay, so if you want to sum these terms till n is equal to 10, it's the equivalent of summing these terms till n equals to 10, starting from n equals to 1. Okay, so what can we do? First of all, you see that the first term is pretty easy. It's a term of a standard geometric progression, so summing that would be easy. It's just going to be the first term, which is x squared. So just write sum sum is equals to, okay, so summing these kind of terms, the x to the 2n formatted terms, you get x squared times x to the 20 minus 1, because it's going to be r to the n minus 1, and then this divided by r minus 1, which is x squared minus 1. Okay, so summing 2 from n equals to 1 to n equal to 10, we just get 10 2's, which is 20. And then this looks weird, but it is also a GP, right? It's also geometric progression, with the first term being 1 over x squared and the ratio being 1 over x squared. All right, so plus 1 over x squared times 1 over x squared to the 10th power, which is 1 over x to the 20 minus 1, and then this complete divided by 1 over x squared minus 1. Okay, so now let's simplify this. This is x squared times x to the 20 minus 1 upon x squared minus 1. Just going to leave it like that, plus 20. What about this one? Okay, so we can multiply the top and bottom by x squared to get rid of this 1 over x squared, and in the denominator we will get 1 minus x squared. What do we do with this 1 over x to the 20? Just multiply the top and denominator, the numerator and denominator, by x to the 20, so that will get rid of this term and give us x to the 20 over here. So it's going to be 1 minus x to the 20 and then 1 minus x squared, but all this divided by x to the 20. Yeah, this obviously this plus sign over here. And what is this? We don't want that. Okay, that's nice. So now let's simplify it further. Okay, so simplifying it further, shit. Okay, so let's simplify it further. You can see that this 1 minus x to the 20 and 1 minus x squared, that is the same as saying x to the 20 minus 1 over x squared minus 1. That just multiply the numerator and denominator by a negative 1. It still keeps the expression completely the same. Okay, so then we can factor out an x to the 20 minus 1 over x squared minus 1 from the first and the last term. So you get x to the 20 minus 1 over x squared minus 1, and in bracket you get x squared and 1 over x to the 20. And yeah, there's this 20. Okay, so this can be simplified further to x to the 20 minus 1 over x squared minus 1 times x to the 22 plus 1 over x to the 20 plus 20. Let's see if this was in the options. Oh yeah, this was in the options. This is the first option itself. So x to 20 minus 1 or x square minus 1 x to 22 plus 1. Yes, correct. Over x to 20 plus 20. Correct. So option A is correct. Let's move to the next question. So well, first of all, just erase this. Right. So I just want to erase all this stuff. Just delete this. Okay. So the next question is that if both x and y are positive and a and b are numbers less than 1, okay, then the sum of the infinite terms of the series, this series, root x and then root of a plus root of x in the bracket plus root x times root a root root a times b plus root x times y, and then root x times, oh, this is root a times b squared, right? So root of a times b squared plus root of x times y squared, and so on. So you can see that this root a got multiplied by root b for this root ab, and then it got multiplied by root b once again to get this b root a, and then this root x got multiplied by root y to get root xy, and then once again by root y to get y root x. So this is another GP. Okay, so let's do this. So let's just see the general form of this term. The general form of the term in the sequence. It is root x times root of a b to the n minus 1. Sorry, what happened? Okay, and then plus root of x times y to the n minus 1, and yeah, that's the general term. Now we want to sum this up, but before doing that, let's just simplify it. So this is the same as saying root of x times a b to the n minus 1 plus x root of y to the n minus 1, which can be further written as root xa times root p to the power of n minus 1. This is supposed to be n minus 1. Okay, and then over here you have plus x root y to n minus 1. That's nice. So this is just a GP. Now we are going to sum this infinite series, and a and b are numbers which are less than 1, and x and y are positive numbers. Okay, wait a second, but what about this y thing? What? Okay, so this is a completely different thing. So 0 is less than x, y, a, b is less than 1. So all 4 of x, y, a and b, these all are less than 1 and positive. That's nice. So now we can use the formula for the sum of infinite terms of a GP whose ratio is less than 1 and still positive. So it's going to be a upon 1 minus r. Here a is the first term and r is the ratio. For these kind of terms, you get, okay, let's just write this down. Sum is equal to, so for these kind of terms, you get the sum being, the first term is root x a, and then divided by 1 minus r, which is 1 minus root of p. Okay, and then for these kind of terms, the first term is x itself, and then the ratio is root y, so plus x over 1 minus root y. Okay, now I think that's it. We don't need to simplify it any further because these options are already coming in the form which we have written it in. So this root of xa, let's just write it as root of ax, that will be better. So root of ax. Okay, so root of ax and then 1 minus root of b, here it is, plus x and 1 minus root of 5. Correct. So this is the correct answer. Okay, so now let's move on to the next question. Okay, so these are 10 questions. We are going to solve all of them. The first is that x, 2x plus 2 and 3x plus 3 are first three terms of a GP, then its fourth term is. So there you go. You want to find the common ratio. Okay, and also the first term. So hopefully this will just be a quadratic equation and we will be able to do it very fast. So let's just do this. 2x plus 2 whole squared is the same as 4 times of x plus 1 squared, which is equal to the product of the first and last terms, which is x times 3x plus 3, which is nothing but 3x squared plus 3x. Wait, where am I writing? Oops, looks like something went wrong. Okay, just switch this off right now. Oh, I was writing here. So, okay, I should have been writing over here. So just erase this. Okay, now we are good to go. So let's do this. It's going to be 2x plus 2 whole squared is the same as saying 4x squared plus 8x plus 4, and this is going to be the product of the first and last term, which is 3x squared plus 3x. Okay, that's nice. So this can be simplified further to give us x squared plus 5x plus 4 is equal to 0. So this can be factored as x plus 1 into x plus 4 is equal to 0. So x is equals to minus 1 or x equals to minus 4. X equals to minus 4. Now let's generate those three numbers. Okay, so the first number is x. Suppose x is minus 1, then the first number is going to be minus 1. Then the next number is 2x plus 2. So 2 times of minus 1 is just minus 2 plus 2. That's going to be 0. And then the next number is going to be 3 times x plus 3, which is once again 0. So here the common ratio is 0. Okay. But this is weird because it should not have gone like that. Because the ratio cannot be 0. That would not make sense. Okay. So I don't think that this is going to be our answer. That's not the GP which we were hoping for. So let's use x equals to minus 4 for this question instead. So the first term is minus 4. Okay, let's just erase this first so that we don't get confused. So the first term is minus 4. The next term is 2 times of minus 4, which is minus 8 plus 2. So it's going to be minus 6. And then the next term is 3 times of minus 4, which is minus 12 plus 3, which is minus 9. So you can see that the ratio over here is 3 by 2. So when you multiply minus 9 by 3 by 2, you get the fourth term. So that's just going to be 27 by 2 in negative. So negative 27 by 2. So that's nice. Let's move on to the second question. The nth term of a GP is 128 and the sum of its n terms is 255. Its common ratio is 2, then its first term is okay. The n term of GP is 128 and the sum of its n terms is 255. The common ratio is 2 and its first term is this is easy. So we will just be using, wait, where is it? Okay, you know what, let's just erase this. Yeah, just give us ourselves some space. Okay, so the n term of a GP is 128, which means that a times r to the n minus 1 is 128. Okay, the sum of its n terms is 255, which means that a times r to the n minus 1 upon r minus 1, this is 255, and we are also given the common ratio is 2, so we will just replace this r by 2 everywhere, so you get a times 2 to the n minus 1 is 128, and a times 2 to the n, which is, okay, so a times 2 to the n minus 1 over 2 minus 1 is just 1, that is equal to 255. So that's nice. Wait, you know what, it's really nice. So you see this equation, I'm going to simplify it further. I will write it as 2 times a to the 8 into 2 to the n minus 1 minus a is equals to 255. And now you can guess why I wrote it like that, because a into 2 to the n minus 1, this is 128, so you can just plug that value in this, and that will basically give us the value of a directly. So we just get 2 times 128, which is obviously 256, minus a is equals to 255. Okay, so that means that a is equal to 1. That was easy. Okay, just erase this now. Okay, let's move on to the third question. So the third question is, if first, second and eighth term of a GP are respectively n to the negative 4, n to the n, okay, and n to the 52, then the value of n is, wow, this is weird. So the first, second and the eighth term of a GP is respectively, okay, let's just do this now. So the first term is obviously n to the minus 4, so the second term is going to be that times the common ratio. So you can say that n to the n is equals to n to the minus 4 times r. Okay, and the eighth term is going to be the first term times the common ratio raised to the 7th power. So you have n to the 52 is equal to n to the minus 4 times r to the 7th. Okay, so first of all, you just want to eliminate this r so that we can find an equation in n, and then we will be able to do this much better. All right, or maybe what we can do is that we, using this equation, we can just find the value of r. Yeah, let's try it out. So using this equation, we can say that n to the 56 is equals to r to the 7. Now if r is a real number, then we can legitimately say that r is equal to n to the 8. Okay, so plugging that in this equation, right, in this equation, first of all, just put a line. Okay, in this equation you get n to the n is equals to n to the negative 4 times n to the 8, which is nothing but n to the 4. So this is clear that n should be equal to 4. That's nice, which implies that n is equal to 4, or n is equal to 1. Okay, in both cases this equation is satisfied, because if n is equals to 1, then the bases are 1. If n is equal to 4, then obviously it is satisfied, right? There's no problem with that. So that's nice. Now what were we supposed to find in this question? Okay, then find the value of n. Oh, that's it, it's either 4 or it is 1. And yeah, that looks correct. Yeah, that's correct. Okay, let's move on to the fourth question. If okay, let ABC form a GP of common ratio r with 0 is less than r is less than 1. Oh, that's nice. So it's a decreasing GP. If A, 2P and 3C form an AP, then R is equal to, okay, let's do this. Okay, so ABC form a GP with a common ratio R. So we know that the middle term is B. So we can say that B squared is equal to AC. Okay, and then you also know that A, 2P and 3C form an AP, which means that 2 times the middle term, which is 4B, is equals to the sum of the first and last term, which is A plus 3C. Okay, so that's nice. Now what I want to do is that I want to multiply. No, let's not multiply it. Let's square this. Okay, let's square this equation. So you will get 16b squared is equal to a squared plus 6ac plus 9c squared. Alright, so now we can input the value of b squared as ac and hopefully we will get a quadratic. So you get 16 times ac is equal to a squared plus 6ac plus 9c squared. That's nice. So that looks like a homogeneous quadratic equation in two variables. So let's solve this. Let's just bring everything in one side. You get a squared minus 10ac plus 9c squared is equal to 0. Let's try to factor it. So you get a squared minus ac minus 9ac plus 9c squared is equals to 0. Okay, so this can be factored as, wait a second. Okay, so this can be factored as you take a common from the first two terms, so you get a times a minus c, and then you take minus 9c common from the next two terms, so you get a minus c is equal to 0. So from that we can say that a minus 9c times a minus c is equal to 0. Okay, cool. So let's come back to our question. What were we supposed to do? Yeah, then what is the common ratio? Okay, so we want to find the common ratio now. So that's going to be nothing but b upon a or c upon a. So we can already see from this that either a is equal to 9c, which means that c upon a would be 1 by 9, or a is equal to c, which means that the common ratio would be 1, but we are given that r is strictly less than 1, which means that a equals to c is not good. So discard this. So which means that a equals to 9c, therefore c by a is nothing but 1 by 9, which is also the common ratio. Okay, let's move on. If the sum of an infinitely decreasing GP is 3 and the sum of the squares of its term is, I think it should be infinite decreasing GP is 3. Okay, and the sum of the squares of its terms is 9 by 2. The sum of the cubes of its terms is, okay, not bad. So suppose the GP is a ar and then ar squared and so on, and when you sum this you obviously get a upon 1 minus r, and we are given that this sum is equal to 3. Okay, and the sum of its square is 9 by 2, so this thing is 3. Wait, what? Okay, and the sum of the squares of these terms, which is obviously a squared plus a squared r squared plus a squared r to the fourth and so on. Well, this is going to be a squared upon 1 minus r squared using the same formula. Okay, and this is going to be 9 by 2, I think. And yeah, squares of the sum of the squares is 9 by 2. This is 9 by 2. Okay, that's nice. So we can just factor this out. We can say that a upon 1 minus r into a upon 1 plus r, that is equal to 9 by 2. So from that we can say that 3 times, wait, sorry, this is supposed to be 9 by 2. Okay, from that we can say that 3 times a upon 1 plus r is 9 by 2, which means that a upon 1 plus r is 3 by 2. That's nice. So from this you got two equations. Just make more space. From this we got two equations. The first equation is that a upon 1 minus r is 3, and a upon 1 plus r is 3 by 2. That is good. So what we can do is that we can divide these two equations to get 1 plus r upon 1 minus r equals to 3 by 2 upon 3. Sorry, upon 3. Right, that should work. Yes, 3 by 2 upon 3. No, wait, sorry, this will not work. Yeah, come on, why is this happening? I think I just missed the whole order. So a upon 1 minus r upon a upon 1 plus r, that would give us 1 plus r upon 1 minus r, which is 3 upon 3 upon 2. So this should be 3 divided by 3 by 2, which turns out to be 2, which means that 1 plus r is equals to 2 minus 2r, which means that 3r is equals to 1, which means that r is equals to 1 by 3. That's nice. So just inputting this in one of the equations, we will get the value of a. Okay, so let's get the value of a now. So a upon 1 minus 1/3 is nothing but a upon 2/3, then that is equal to 3, which means that a equals to 2/3 times 3, which is just 2. A should be equal to 2. Okay, cool. So now what was the question? Yeah, we wanted to find the sum of the cubes of its terms, right? That sum. So it would be a cubed plus a cubed r to the 6th power and so on, which is a cubed upon 1 minus r cubed. Now we know that the value of a is 2, so this is going to be 8 upon 1 minus 1 over 27. Now that's going to be 8 into 27 upon 26. Yep, and I won't be doing all the calculation. This is the final answer. Just erase everything now. Erase it. Okay, let's go to the next question. But before that, let's erase this. Okay, so the next question is okay, we did the 5th one. Let's move on to the 6th one. Okay, if the sum of the first two terms of a GP, of an infinite GP, is 1, that means that a plus ar, these are the first two terms, this sum is 1. Okay, and every term is twice the sum of all successive terms. Then its first term is, wow, this is weird. So twice the sum of the successive terms, okay, sum of all the successive terms, which is a plus ar and all the way till ar to the n minus 1. These are n terms. When you twice this, right, the sum of these n terms, this is going to be a r to the n. Okay, so what can we say from this? We can say that 2 into a into r to the n minus 1 upon shit this, why does this keep happening, r to the n minus 1 upon r minus 1, that's going to be a times r to the n. Okay, so what can we do with this? Okay, let's just simplify this now. So you get 2ar to the n minus 2a. You know what, just get rid of this a. Let's just cancel away these a's. So cancel. So that would give us 2 times r to the n minus 2 is equal to, well, r minus 1 times r to the n. That is, this is very creepy. Okay, so you just get r to the n plus 1 minus r to the n. Okay, so what can we do with that? So you can put 3 times r to the n over there. So 3 times r to the n. Okay, minus 2 is equals to r to the n plus 1. Okay, but what now? We seem to be stuck. There should be some way to get out of this. Maybe we could use the value of a somehow. Well, no, that would just get cancelled, so there's no point in doing that. Okay, so this, wait a second, you know what, if this works for all values of n, then why don't we try putting value of n such that this gets simplified a lot. So let's put the value of n as 1. Well, yeah, that would mean that 2 times of a is equals to a. That's weird. No, 2 times of a equals to ar, obviously. So putting the value of so putting the value of n as 1, what we get is that 2 is equal to r. Oh, well, that was easy. I mean, this was really easy. This has a more of a functional equation kind of essence to it. So you just put the value of n as something, and then you get the value of r directly. So what does this mean? 3 times r to the n minus 2 equals to r to the n. Does this always work? Well, yes, it works. Because look at this, 3 is nothing but 2 plus 1. So that would mean that this would be 2 to the n plus 1 plus r to the n and then minus 2, which is equals to r to the n plus 1. Wait a second. Something is wrong in this, maybe. This is weird. So, but whatever, just got the value of r, we just move on. So what were we supposed to find? And every term is twice the sum of all successive terms. Then its first term is okay, so just put the value of r as 2 in this, so you get a equals to 1/3. This is really weird. I mean, I was not expecting something like that to come out. I don't even know if this equation actually works or if it doesn't. So if you put 3 times 2 to the n, you get 2 to the n plus 1 plus 2 to the n minus 2 is equals to 2 to the n plus 1 minus 2 to the n. So this cancel. So that would mean that 2 to the n plus 1 is equals to 2. Wait, no, something is okay, whatever, just move on. Okay. um Find the least value of n for which 1 plus 3 squared plus 3 to the n minus 1 is greater than 100, greater than 1000. Okay, so find the least value of n for this, for which this happens. So you got 1 plus 3 squared and all the way till 3 to the n minus 1 is greater than 1000. Okay, so using the formula for sum of n terms of a GP, just get, well, a is 1, so you just get r to the n minus 1 or r minus 1. In this case it is going to be 3 to the n minus 1 upon 3 minus 1, and this is supposed to be greater than 1000. Okay, so 3 minus 1 is just 2, so you get 3 to the n minus 1 is greater than 2000, which means that 3 to the n is greater than 2001. Oh wait, this is not what I wanted to write. 2001. Okay, so you want to find some power of 3 which is greater than 2001. Let's start writing the powers of 3. So 3 to the 1 is equal to 3, 3 to the 2 is equal to 9, 3 to the 3 is equal to 27, 3 to the 4 is equal to 81, 3 to the, well, skip to 3 to the 6 now, 729, and I think we are close. So 3 to the 7, that would be equal to, let's just do this fast now. 9 times 3 is 27, so 7, 2 carried on, 2 carried on, and then 6 and 2 is just 8, and you got 21. Oh, this is bigger than 2001, so that's correct. This is what we want. Okay, just why okay, this is what we want. So our answer is 7. So n should be 7 such that this would be satisfied if n is an integer, obviously. Okay, let's move on to the next question. Three numbers form an increasing GP if the middle term is doubled. Okay, three numbers form an increasing GP. If the middle term is doubled, then the new numbers are in AP. The common ratio of the GP is okay. Three numbers, say A, B, and C. These form a GP, which means that B square is equals to AC. Now, if the middle term is doubled, which means that you have 2B, then that forms, so A and 2B and C, these form an AP, which means that 4B is equals to A plus C. That's nice. So once again, let's just square this. So you get 16B squared is equals to A squared plus 2AC plus C squared. Now let's put the value of B square as AC. So you get 16AC equals to A squared plus 2AC plus C squared. Okay, now let's just put everything on one side. So you get A squared minus 14AC. That's weird. Plus C squared is equals to 0. I think something's going off. Okay, whatever. Why is this even here? Okay, so now let's divide this by A squared. So that would give us 1 minus 14 of C by A plus C by A squared is equals to 0. Okay, now you can use the fact that C by A is just the common ratio, say R. So you would get R squared minus 14R plus 1 is equals to 0. Now we just need to use the quadratic formula. I don't think this is correct because we're getting some weird expression for this. If the middle term is doubled, then the new numbers are in AP. The common ratio of the GP is. Okay, that's nice. I think this is correct. So far good. The middle term is double. Yeah, this is correct. This is completely correct. So let's use the quadratic formula now. So r is equals to plus minus root b squared, which is obviously 14 squared, minus 4 because a and c are 1, so plus 14, and then this complete divided by 2a, which is just 2 in this case. Okay, wait, what? What happened? Okay, so just get myself some more space. So that means that r is equal to, well, plus minus root of 14 square minus 4, you can factor out a 2 square from both of them. So this would be plus minus 2 root of 7 squared minus 1 plus 14, and this complete divided by 2, which is just equal to plus minus root of 49 minus 1 is just 48 plus 7, because those two cancels away. Yeah, those two cancel away. Now 48 plus 7 is plus or minus 2 root of 12 plus 7, which once again is just plus or minus 4 root of 3 plus 7. Now here's the deal. If you take the negative root 48 version of this, what you get is that the ratio is less than 1 and greater than 0. So the yeah so the GP would be a decreasing GP, which is not good because we wanted an increasing GP. So you have to take the positive version of this. So you get 7 plus, okay, so r is equals to 7 plus 4 root 3. That's nice. That's the answer. And let's move on to the next one. It's the product of 3 terms of a GP. Just erase some stuff first so that I can get more space. Okay, so you have a product of 3 terms of a GP is 216, and the sum of their products taken in pairs is 156. Then the greatest term is, okay, let's do this. So suppose the terms are a upon r, a and ar, and the product is 216, which is 6 cubed. You can say that a cubed is equals to 6 cubed implies that a is equals to 6 because a is a real number. Okay, so now you know that the sum of their products taken in pairs is 156. So you have a upon r into a, which is just a square upon r, plus a into ar, which is just a squared r, plus a upon r into ar, which is just a squared, that is equal to 156. Okay, so now we can just factor out an a squared from this and put the value of a as 6. So a squared would be 36. So 1 by r plus 1 is equals to 156 divided by 36. That's nice. Let's see if this gets simplified further. Looks like that this can get simplified. So this is equal to 12, and then 36 for 6, and then this is 6 over there, which is 13 over 3. Okay, so now let's make a quadratic out of this. So you get 3r squared plus 3r plus 3 is equals to 13r, which means that 3r squared minus 10r plus 3 is equals to 0. Now you can factor this as 3r squared minus 9r minus r plus 3 is equals to 0, which gives me 3r times r minus 3 minus of r minus 3 is equals to 0. Alright, so from that we can say that 3r minus 1 into r minus 3 is equals to 0, which implies that r equals to 3 or 1 by 3. So that means that those three numbers are going to be, the middle term is obviously 6, the lowest term is 2 and the greatest term is 18, I think. So this is our answer, the greatest term. Okay, let's go to the 10th question now. So it says that let a sub n be the nth term of a GP of positive numbers. Let the summation from 1 to infinity of a sub 2n, okay, is equals to alpha, and summation of from n equals to 1 to infinity to 100 of a sub 2n minus 1 equals to beta, such that alpha is not equal to beta. Show that the common ratio is alpha by beta. Okay, this is weird. Let's just write this down in a form which we can understand. So it's going to be a sub 2 plus a sub 4 plus a sub 6, so on till a sub 200. This is equal to alpha, and you have a sub 1 plus a sub 3 plus a sub 5, so on till a we put 100 in this, you get 200 minus 1, which is obviously 199. This is equal to beta. Okay, so what can you do from this? So suppose the common ratio is r, then you can see that this is having a common ratio r squared, like the second term, the fourth term, the sixth term. This series is having the common ratio r squared, and similarly this series is also having the common ratio r squared. So let's just write that down. So you know what, this sum is going to be the first term is a sub 2, the common ratio is r squared. How many terms are there? Well, from 2 to 200 is 1 to 100, obviously. It's like, yeah, there's obviously 100 terms out to the 200 minus 1 upon r squared minus 1. This is alpha. And then over here you have a sub 1 into the same stuff, okay, upon r minus 1. This thing is beta. Well, that's nice, because what we can do is that we can just divide these equations. Just divide this. So from that we get a sub 2 upon a sub 1, which is just the second term upon the first term, which is nothing but the common ratio, that is equal to alpha upon beta. Easy. This was easy. So that's exactly what they wanted us to show. So these 10 questions done. Let's move on to the next part, which is going to be these questions, right? 22, 26, 1, 2, 3, 4, 5. It's 5 questions in there. Okay, break the numbers 155 into 3 pairs so that the obtained numbers form a GP. Okay, we break the numbers 155. I think this is supposed to be 155 into 3 parts. The first term being less than the third one by 120. I think break the numbers 155 to 3 parts that the obtained numbers form a GP. I don't know what this really is. I think they are talking about the factors of 155. Well, I don't think that this is a nice question. This is not a nice question, because we don't know what they are even talking about. So just going to cross this out. We won't be doing this question. Okay, let's do the 23rd one. Find 3 numbers, okay, in GP such that their sum is 14 and the sum of their squares is 84. Okay, that's nice. So suppose these 3 numbers in GP are, say, AR and AR squared, and you're giving that the sum of their sum is 14. Yes, sum is 14. And the sum of the squares is 84. So a squared plus a squared r squared plus a squared times r to the fourth. No, r to the fourth. Yeah, correct. That is going to be 84. Okay. Uh, what do we have to do? Find those three numbers. Okay, that's nice. I think we have already done such a question in the past. Let's see if we can do this once again. So we will be using the formula for um, the sum of a GP. So this is just going to be a times r to the 3 minus 1 upon r minus 1, which is 14. Okay, and over here what you get is a square times r to the 6th minus 1 upon r squared minus 1. That is, yeah, that's 84. Okay, so what we can do instead, we can first of all square this. So that would give us a square times r cubed minus 1 squared upon r minus 1 squared is nothing but 14 squared, which is 4 into 7 squared. Now we can divide this equation by this equation to uh, eliminate those a squares. So you would get r cubed minus 1 whole squared upon r minus 1 squared, and then you divide it by this thing. Now I'm going to write r to the 6th minus 1 as r to the 3rd minus 1 into r to the 3rd plus 1, so that we can simplify some of the terms. And similarly I'm going to write r squared minus 1 as r minus 1 into r plus 1. Sorry, what was this? Okay, and this is going to be 4 into 7 squared upon 84, which is just 7 squared upon 21, which is 7 upon 3. I think we have done this exact question once. Well, whatever. Now let's simplify this. Okay, so r cubed minus 1 squared upon r cubed minus 1 is just r cubed minus 1. And then over here you have r minus 1. And then you have r plus 1 upon r cubed plus 1. And this is equal to 7 by 3. Now you can use the formula for sum of cubes to write r cubed minus 1 as r minus 1 times r squared plus r plus 1. So it will cancel with r minus 1, like one of the factors will cancel with r minus 1, and you will be left with r squared plus r plus 1. And similarly you can write r cubed plus 1 as r plus 1 into r squared minus r plus 1. So you will be left with r squared minus r plus 1, because those two r plus 1 will get cancelled. So you get 7 by 3 over here. Yes, we have done this once. Yup. So that means that 3r squared plus 3r plus 3 is equal to 7r squared minus 7r plus 7, which can be written as 4r squared minus 10r plus 4 is equals to 0. Okay, so dividing by 2, you just get 2r squared minus 5r plus 2 is equals to 0, which means that 2r squared minus 4r minus r plus 2 is equals to 0. So 2r times r minus 2 minus of r minus 2 is equal to 0. So from that we can see that 2r minus 1 into r minus 2 is equals to 0. So r is equals to half or 2. That's nice. Now let's just plug that in one of these equations to get the value of a. So let's just use 14 equals to this thing. Yes. So you know the value of r now. Suppose you take the value of r as 2, And yes, we have already done this question once, so I know that we are going to get the same three numbers even if you take um, the value of r as 2, or even if you take the value of r as 1 by 2, you still get the three same numbers. So suppose you take the value of r as 2. Okay, so suppose you take the value of r by 2 as 2, then what you can get is 2 times 2 times sorry, wait, what? Sorry, a plus 2a plus 4a is equals to 14, which means that 7a equals to 14, so a is equals to 2. That's nice. So this question is done. This was quite lengthy, and I think we have already done this, so I think it was a complete waste of time and effort. But whatever, this question is now done. Let's move to the next question. Okay, so the next question is determine the first term and the common ratio of the geometric progression, the sum of whose first and third term is 40 and the second and fourth term is 80. Okay, that means that you have the sum of, wait, what? Yeah, the sum of the first and third term is 40, so you have a plus ar squared is equals to 40, and the second and fourth term, their sum is 80, so ar plus ar cubed is 80. Now I can be wise and I can just factor out an r from the left hand side to get a plus ar squared, and this is going to be equal to 80. So you can see that this thing is 40, so 40r is equals to 80, which means that r is equal to 2. Easy as that. Let's just put the value of r in this equation, so that gives us a plus 4r is equals to 40, so 5r equals to 4, sorry, 5a, sorry, this is supposed to be a. 5a is equals to 40, which means that a is equal to 8. That's nice. So determine the first term and the common ratio of the geometric progression. The sum was the sum of whose, wait, what? Yeah, the first term and the common ratio. Okay, so you got it. The first term is 8 and the common ratio is 3, so a should be the correct option. Okay, I don't remember what was this. Yeah, I think we got the value of a as I don't remember, whatever. I don't remember the answer of 23rd question, but we did it and it was an easy solve because we already did this once. If a, b, c are in gp, then a to the negative 1, b to the negative 1 and c to the negative 1 are in, well, they also are in gp. Easy. I mean, this question is like really easy. If pqr are in ap, then p to the, okay, and the pth and qth and rth term of any gp are themselves in, obviously they are also in gp. This is just common logic that p, q and r terms are in ap, which means that the difference between q and p and r and p is same. So when you take the ratio of the qth term and pth term, that will be exactly the same amount of r's as the ratio of rth term and qth term. That was easy. So that's it. We have done all the questions of my homework which were remaining. And yeah, so see you later.